I'm sorry, did you get me in class this morning?
Yeah. hmm
Okay.
And I'm just mainly looking for 4 people that haven't showed up yet, but everyone here today was here yesterday, so we're good. All right, so we're going to pick up in 2.2 in college algebra. And this deals with functions. So we'll go through a few definitions first, and then we'll get into what their problems are going to be. So first, they talk about what we call a correspondence. And a correspondence is just a relationship between a domain and a range. And remember, really the domain would be what we consider our x values. And the range is what we would call our y values. Okay, so a correspondence just says we got some x's and some y's, and they try to show a relationship between them. What we're more worried about is a special correspondence that we call a function. Okay, so a function is a correspondence in which each domain value has one and only one range value. Okay, so a correspondence shows you a domain and a range, but a function is a special correspondence in which each of those domain values has only one range value. It's like if you're getting paid and you work 40 hours, you don't want a choice for your pay. You want that to be one amount when you work them 40 hours. Okay. So we're going to look at some charts and tell whether these are functions or not functions. So these examples will say determine whether the correspondence is a function. All right, so number one, let me let someone in. They got our domain listed on the left side, and then my range will be listed on the right side. So on this chart on the left side, I got 9, 24, and 18. For the range, I got 25 and 7. So the 9 points to the 25, 24 points to the 7, and then my 18 points to the 25. So the question, is that a function? So remember, my definition up here said if it's a function, each of these domain values has only one range value. So y'all, what you got to look at is the 9 first. The 9 only points to the 25, so it's only got one range value. The 24 only points to the 7, so it's only got one range value. And then the 18 in the domain only points to the 25, So it only has one range value, so this would definitely be, yes, a function. So notice, they can share ranges, but none of these domains can point to more than one of those range values, okay? An example of where a domain might share range values is if you was a salary worker, right? It don't matter how many hours you work, you still get the same pay. That's still a function. You just can't have each of those domain values going more than one range. All right, so we're going to continue on them same kind of problems. So the second one, we got domain and range. Yo, in the domain, I got -5, 4, and 7. The range has a 5, and all three of these are pointing at the 5. So the question, is that a function? And once again, if you notice, all
Yes.
these, definitely, right? Because all these domains just point to one range. So you're good on that. That is definitely, yes,
Yes.
a function. All right, y'all, for this one, they're telling me my domain is going to be a city, and my range is going to be the team. Now, I got 2 cities. I got Detroit, and I got Boston. The teams are Lions, Tigers, Pistons, Celtics, Bruins, and Red Sox. So Detroit points to the 3 top teams. Boston points to the 3 lower teams. So, is that a function?
No.
Oh, I got you on that, didn't I? Because remember, you got your domains over here. Your domains are the Detroit and Boston. Remember, for this to be a function, they can only point to one team.
One way.
Mm-hmm. So since they're pointing to 3 teams each, you got to put no, not a function. Okay? So remember, focus on your domain and make sure they've only got one of those ranges, okay? All right, y'all, next we're going to look at function notation. So when I say function notation, I'm talking about something like f of x. So this is called f of x. But y'all, this is just symbolism. If an x is there, it tells me what the variable is. So this tells us the variable. So a lot of times in sciences, you might have an f of t because t is time, and time's the main variable in the sciences. In here, we'll probably have x's here a lot. So it tells me the variable. Also, it tells me another thing. If a number is given, then that number is substituted into the expression. Okay, so it tells me the variable, and then if I got a number there, it tells me what number I'm going to be putting into that variable. Okay, now the f of x is just symbolism. It's not part of the equation. We just sort of use it for shorthand. Instead of me saying, hey, what's the value of this expression when you put a 5 in for the x? I can say, hey, find me f of 5, and that'll let you know that I wanted you to put a 5 in for those x's. So really, this is just symbolism. So y'all watch this. We're going to be given a function, h of x equals x plus 17. We're going to find h of 0, h of a -1, h of a -2, h of a +2, and h of a c plus 5. So if you notice, this is basically 1, 2, 3, 4, 5 problems, because I got to find all 5 of these values. The equation is h of x equals x plus 17, so they're letting me know x is my variable. And on this one, when they put a 0 in for the x, that means when I take this equation, h of 0 is going to take this equation, x plus 17, and we're going to put a 0 in for that x. Now, the left side h of 0 is just symbolism. All you want to do is work the right side, so that 0 plus 17 will give you 17. So h of 0 equals 17, and then we would work our h of a -1 next. So h of -1 wants me to take this equation and put that -1 in for the x, so I get a -1 plus 17. So y'all, we got unlike signs, so I'm going to subtract and get the sign of the larger number. So 17 minus 1 is 16. Larger number is positive, so that'll be a positive 16. Hey, so they're not too bad. You just got to get used to, these are the numbers you're putting in for your x's. H of -2 is next. So I'll replace the x with a -2, so that'll give me -2 plus 17. So once again, I got unlike signs. So 17 minus 2 is 15. Larger number is positive, so that'll stay a positive 15. Now, y'all, we got what, 2 more? Next one is what, h of 2. So we take the expression and put a 2 in for the x. So that'll give me 2 plus 17. And let's see, 2 plus 17 gives us 19. And y'all, the tricky one, the h of c plus 5. So since they got this c plus 5 inside these parentheses, that means this x has to be replaced with the c plus 5. So that'll give you c plus 5 plus that 17 at the end. So you still got x plus 17. X is now c plus 5. And y'all, guess what? I can go further with this one, because I got like terms over here. So in this problem, I would add my like terms together. So I get my c plus 5 plus 17. That's what, 22. Now I got c plus 22. Those are not like terms, so I would stop there. Now y'all want to see something cool? 4 of these that had numbers here, I can do on the calculator. The one with the C, I really can't do on the calculator, what I'm about to show you. But y'all watch this. I'm going to go to y equals. I'm going to clear that out. And I'm going to put in the x plus 17. X plus 17. Now, I'm not even worried about graphing it. I want to look at the table. So watch this. When I hit second graph and look at my table, what was my first value? 0. So let me see, where's my 0? And that looks like the 0 right there. And if you look over here, I get a y value of 17. If I look up here at -1, I got my 16. Oh, where am I at? Let me see if I put in the right x plus 17. Yeah. So all these numbers, when I look through my table, will give me values that we had on here, okay? And then I finished with what? 2. So there was that for 2, which gave me 19. So if you plug those into the y equals, you can find these values going through here, okay? And every one of mine was sitting right over there on those y values. So look for the x's and then see what those y values are, and those are to match what we're getting on here, okay? All right, moving on. All right, so this is the same thing. This time they're giving us h of s equals 4s plus 8. We're going to find h of 10, h of a -2, and h of a 6.5. So they're going to keep you honest with a decimal once in a while or a fraction. So it looks like we got 3 problems here. So first we'll find h of 10. So h of 10 wants me to take this equation and in place of the s, put a 10. So I'll have 4 times 10 plus 8. All right, so order of operations, I got to multiply first. So 4 times 10 is 40 plus my 8. So now I can add, and 40 plus 8 will give us 48. But y'all watch this. I can put in, now on the calculator, I can't put in the s's and graphing. So I'm going to put in 4x plus 8. I'll just use the x as my variable on the calculator. Now watch this. When I go to second table, find h of 10 down here. So at h of 10, I get a y value of 48. All right, h of -2. Same thing, I'll take the 4 times the -2 plus 8. So let's go see what we should get on a -2. I should get a 0, so let's see. 4 times -2 is -8 plus 8. And y'all look at that, -8 plus 8 is definitely 0. And then finally, I got an h of a 6.5. So notice I don't have the decimals on here. You would have to ask your calculator to ask for the values for that to be done. Okay, so let me see. If I was going to do that, where it says table set, I would hit blue button. And you see where it says independent is auto? I'm going to put that on ask and then go back to my table. So see down here, it's saying, hey, what X do you want? I want 6.5, enter. And what'd that give me for a y value? That looks like, what's that, 24? So we'll see if that's right. Oh, that might be 34. I can't tell.
34.
Okay, that's 34. So let's see if we get that. So let me clear that. 4 times 6.5 is going to give me 26. And y'all look at that. 26 plus 8 is definitely 34. So you can get it to do that on the calculator if you change your table down here from automatic and have it ask on those, okay? If it's on automatic, it's just
Mr.
going to go.
Eugene,
Yeah. I hear you.
how do I get back out of, how can I get out of the y equals and just go back to basic math?
Always hit the second button and the mode
Mhm.
button. You see how it says quit above it? So hit the
You said
second button.
hit second and,
So see, I'm on the graphing. I'll hit the two
Yeah.
buttons right by each other.
second and mode. Oh,
Uh,
okay. Thank
And
you.
then it'll pull you back to a regular screen there.
Yes, sir.
Okay.
Thank you.
All right, no problem. All right, y'all, next one has f of x equals absolute value of x plus 4. They want me to find f of 1, f of 4, and then f of a minus 4. Now, if you did it on a calculator, you could do the first two, the f of 1 and the f of 4. But since this one has a variable, you wouldn't be able to find it on the table, okay? So let's find these by hand. I'm going to find f of 1. That means I'm going to replace the x with a 1 and then add my 4 at the end. Treat absolute value like parentheses. It's the first thing you got to do. So the absolute value of 1 would be a 1, bring down to plus 4, and then 1 plus 4 would give us 5. Then we would do f of 4. That'd be the absolute value of 4 plus 4. You know, here we go. Absolute value of 4 would be 4. And 4 plus 4 would give me 8. Now remember, you got absolute value on this calculator. If you hit math and arrow over to the number, first thing you see is ABS, so you would hit enter. And then you can put that 4 in there and see what you get. And you notice I got a 4 like we said, okay? All right, what was next? F of a minus 4. I didn't really like this one too much because, y'all, we're going to put an a minus 4 in the parentheses, and then we have a plus 4 on the outside. What happens on this problem, though? We cannot simplify this. Right? If a is negative, this will come out positive. If the a was positive, it would come out positive, but it would be a different number. So on this one, since we don't know what that variable equals, we can't really simplify this one. So this one is not able to simplify. I don't like when they give us problems where you really can't do nothing to them, but y'all, since we don't know the value of that a, we can't go no further. Hey, y'all, moving on. This one's going to give us f of x equals x to the third. So now we're about to see y'all's exponent rules. We're going to find f of 0, f of a negative 1, f of 3, f of 10, f of -3 and f of a -5a. I'm going to turn my paper over. I'm getting curling. Let me put my calculator like that. All right, so this is basically 1, 2, 3, 6 problems in one. So let me start with f of 0. That wants me to put a 0 in for that x. So I get 0 to the 3rd power. And y'all look at this. 0 to any power is going to be 0. So f of 0 is 0. Then I would find f of a -1, which will be my -1 to the 3rd power. So y'all, this is -1 times -1 times -1. And if you wanted to do that on the calculator, punch in your -1, use that caret key to put in your exponent of a 3, hit enter, and you still get -1. All right, what was next? F of 3. So that'll be 3 to the 3rd power. So that's 3 times 3, which is 9. And then 9 times 3 gives us what? 27. All right, F, what was that next? 10? All right, watch this. I'm going to put a 10 in for my variable and raise it to the 3rd power. And these exponents will make things grow really quick because 10 to the 3rd power is 10 times 10 times 10. And y'all, that shoots us up to 1,000. And I'll tell you what, basically when you got 10 raised to an exponent like this, it's just 1 followed by that many zeros. So my answer was 1 followed by 3 zeros on that, okay? Oh, what I have next? F of -3. That's going to equal -3 to the 3rd power. So -3 to the 3rd. That's going to end up as a -27. And y'all look, the tricky one's probably going to be this f of a -5a. Because in for that x, I'm going to put that -5a and raise all that to the 3rd power. Let me tell you, this exponent affects everything inside them parentheses. So this is basically -5 to the 3rd power. So watch this, -5 to the 3rd power. It's going to give you -125. But what y'all going to do with that a? You got to treat the a like it's got an exponent of a 1 by it. And when you got variables raised to exponents like this, you multiply those exponents. So 1 times 3 would be 3, so that's going to give me a to the 3rd. Okay, so y'all remember that when you got a variable inside parentheses raised to an exponent like that, you got to treat the variable like it's got a 1 for its exponent and then multiply. Now we basically was doing that with the 5, but all we had to do was cube that -5 either way you went, okay? All right, so we got a formula. We're given f of c equals 9/5c plus 32. Anyone know what that formula is for? Oh, they're slacking on me these days. Y'all, that F, this is Fahrenheit temperature. This formula will find you the Fahrenheit temperature given the Celsius temperature. Okay, so this finds the temperature in Fahrenheit. Oh, I don't know how to spell that. I'm just going to try. I think that's close. Gives the temp in Fahrenheit when knowing the temp in Celsius. Okay, so if you know the Celsius temperature, plug it into that and get the Fahrenheit temperature. An example would be the freezing point in Celsius is 0. So that would be a 0. 0 times 9/5 is 0. And 0 plus 32 is 32, which would be the freezing temperature in Fahrenheit. Okay? And then they got formulas that you can find Celsius given the Fahrenheit. So we're just worried about this one. So what they want to know is what Fahrenheit temperature is equivalent to -5 degrees Celsius. So really what this means is I'm finding F of a -5, because that's the temperatures in Celsius, right? So I'll put this -5 in for the C. So I'm going to have 9/5 times -5 plus 32. Now I'm going to tell you, they were nice picking a 5 because the 5s cancel. You can cancel that -5 and 5, making that a -1. So let's see what happens. 9 times -1 is -9 plus 32. And then -9 and 32, unlike signs, so I subtract. 9 from 32 gives me 23. Larger number is positive, so that answer will stay positive. So let's see. On the calculator, you can do this. You can do parentheses 9 divided by 5 times -5 plus 32. Hit enter, you get 23. Okay? So y'all can do that, get you some Celsius temperatures and try to convert them into Fahrenheit, okay? So this is just showing you an example of how you can use those function values. All right, y'all, so now we're going to get back into graphing. Donna Maria, that's all right. All right, we're going to graph the function f of x equals -2x plus 2. Now, y'all, on this one, they're giving you a table to set up. They're giving me 3 x values, -2, 0, and 2. So they're basically giving me some of the values to use on this graph. And then we'll see, I'll plot this once I see how big these values are going to get over here. So same thing we did in chapter 1, section 1, except now they're giving you some values to use, okay? So that -2 means I'm going to first find f of -2 to get that y value. So you would take this equation, -2 times the x, which will be a -2 plus 2. So the equation looks the same other than I replace the x with the first number. So here we go, -2 times -2 is going to make that a +4 plus 2, and then 4 plus 2 will give us 6. Then I would find f of 0 That's going to be negative 2 times 0 plus 2. Y'all, negative 2 times 0 is 0. And 0 plus 2 gives me 2. So I would put my 2 there. But we knew that because 2 is my y-intercept, which means when x is 0, that's my y-intercept. And y'all, one more. What we got to find? F of positive 2. That's going to equal negative 2 times 2 plus 2. So negative 2 and 2 give me negative 4 plus 2. Unlike signs, 4 minus 2 is 2. Larger number is negative, so that answer will be negative. So that my last y value would be a negative 2. But y'all remember, you could have went to y equals and put that in, negative 2x plus 2. And when you went to the table at negative 2, there's my 6. And then if you look down here at 0, there's my 2. And then down here at y equals 2, there's my negative 2. Now, let's plot this. So the first point I'm going to plot is negative 2, 6. So let me make this go about, there's 5. So I'll go out 6 on this. Now remember, I'm doing this by hand, so my lines might not be perfectly straight. So the first one was negative 2, 6. So I come over here to negative 2 and go up to the 6. Then I got 0, 2, which is going to be on the y-axis here. So start at 0 and go up 2. So now I can tell what my line's going to do. So the last point was over here at 2, negative 2. And if you notice, I got a line that goes down, and watch this, verified on the calculator. There's that line going down. So y'all, these aren't too bad. You just gotta focus on these equations and then what numbers you're actually putting into that, okay? All right, y'all, so moving on. So it looks like we'll have one more and then we'll do a break. So how about f of x equals 2 plus absolute value of x. Now, y'all, we'll say this. Although they're giving us 3 values to plot, when you plot that first one on the Math Lab, it only takes 2 points to draw a line, okay? So use the line tool and only 2 points. This one has absolute value. So when we graph it, it's going to be a V, okay? All right, so let me find what table they're giving us. And then an x, f of x. F of x is the same thing as a y, okay? So sometimes you'll see us put a y there. Sometimes you'll see us put an f of x. But you got to get used to f and x and y are the same thing. All right, they want, ooh, they gave me 5 numbers here. Negative 2, negative 1, 0, 1, and 2. Remember, this is going to end up being a V since it's absolute value, okay? So we just got to find, when we plot this in MATLAB, we always want to start with that bottom point, which will be the middle number here, okay? Where the 0 is. All right, so let's find f of negative 2. F of negative 2 is going to be 2 plus absolute value of negative 2. Bring this 2 down. Absolute value of a negative 2. If you hit the math and go to number, hit enter on the absolute value, put in a negative 2. Absolute value -2 is a +2. Remember, once it comes out of those bars, it better be positive, okay? All right, y'all, 2 plus 2 gives us 4. So when x is -2, y is 4. So then I would put in a -1. That's going to equal 2 plus absolute value of -1. So here we go. 2 plus absolute value of -1 is 1. And 2 plus 1 gives us 3. All right, then we got what? F of 0. That's going to be 2 plus absolute value of 0. And y'all watch this. Absolute value of 0 is 0. So I get 2 plus 0. 2 plus 0 is 2. Now, since we know absolute value graphs are symmetric, we should get a 3 here and a 4 here. So let's see. F of 1 is going to be 2 plus absolute value of 1, which will be 2 plus absolute value of 1 is 1. And 2 plus 1 gives me 3. But y'all knew that because I knew these graphs were symmetric. And then finally, F of 2 is going to be 2 plus absolute value of 2. So that's going to be 2 plus absolute value of 2 is 2. And 2 plus 2 gives me 4. So when you graph this, first point to plot in MyMathLabs is the vertex point. Okay, so the vertex point is just that little V down here. So on this one, you'll plot the vertex, and then one of the sides, you just plot one of the sides, it'll draw that whole graph for us, okay? All right, I'm going to turn my paper over. I'm getting a little curvy. All right, so what I'm going to do, I'm going to stop sharing for a second. I'm going to pause this and go back to my screen. So continuing in 2.2 still. All right, this one they're giving me f of x equals x squared minus 4x minus 3. All right, this one they're also giving me a table. So it looks like 0, 1, 2, 3, and 4. So 5 x values again. So I'm going to find 5 y values and then show you how I would graph this one. Since this has an x squared, we would use the 3-point quadratic tool for this one, okay? All right, so f of 0. Now notice this one has 2 x's. So since it has 2 x's, I got to put a 0 in for both of these x's. So I got 0 squared minus 4 times 0 minus 3. 0 squared is 0. Minus 4 times 0 is 0. Minus 3. And 0 minus 0 is 0. 0 minus 3 is a -3. And that happens every time you put a 0 in for variables. If the variable's in every term, then the answer will always be that number at the end. All right, what's next? F of 1. So that'll be 1 squared minus 4 times 1 minus 3. So 1 times 1 is 1, minus 4 times 1 is 4, minus 3. So let's see what that gives us. 1 minus 4 is negative 3. Negative 3 minus 3 is negative 6. And y'all, this is just like the others. Remember, you could plot that in your y equals and get all these values off that table, okay? All right, f of 2 will be 2 squared minus 4 times 2 minus 3. All right, 2 squared, 2 times 2 is 4, minus 4 times 2 is 8, minus 3. All right, let's see what we get. 4 minus 8 is negative 4. Negative 4 minus 3 is negative 7. Courtney, I already called you. Or, I mean, I already seen you as present.
Okay, so yeah, I didn't know. I didn't want to be rude and like say something.
No, you're good. So that was what, negative 7. Next was f of 3. That'll be 3 squared minus 4 times 3 minus 3. But it looks like these are just going down by 1 each time. So let's see. This might be a little different. 3 squared is 3 times 3 is 9. Minus 4 times 3 is 12. Minus 3. So let's see what I get. 9 minus 12 is negative 3. Negative 3 minus 3 is negative 6. So now I'm starting to see my symmetry, remember. These parabolas, once you got that middle point, you start seeing symmetry on either side. So I bet this one should match that one and give us a negative 3. So let's see. That'll be 4 squared minus 4 times 4 minus 3. So 4 squared is 4 times 4 is 16. Minus 4 times 4 is 16. And then minus 3. And y'all look at that. 16 minus 16 is 0. 0 minus 3 is negative 3. Okay, so on this one, if I was plotting this one, I would plot that first. And then I would plot one on each side, okay? So first point to plot. Okay. So let me do that by hand real quick. Or attempt to do it by hand. Let me pull that down a little bit. So that's my X and my Y. Oh, it looks like my Y's go to negative 7. So I'm just going to make everything go out about 7. All right, so I had 0, negative 3. So 0 and down 3 puts me right here. Then I had 1, negative 6. So here's 1 down to negative 6. Then I had 2, negative 7. So that'd be down here at negative 7. And then it looks like it's going to start going back up. So here's 3, negative 6. And then here was 4, negative 3. So that it should come up like that. Now it'll be more curvy. It's just because I'm drawing my stuff so close. And then y'all watch this. Let's go to the graph, clear that, and put in x squared minus 4x minus 3. Go to the table. There's my numbers. For I started at what, 0? There's negative 3, negative 6, negative 7, and then at 3, negative 6, and 4, negative 3. So my table matches. And let's hit graph. And it should throw it over there like mine. And there you go. Alrighty, so the last thing we look at in this section is what we call the vertical line test. The vertical line test. And remember, vertical line goes straight up and down, okay? So it's an up and down line. So here's the thing about the vertical line test. If a vertical line can intersect a graph more than once, the graph is not a function. So it is not a function. To be a function, it can only intersect it once along that graph. Okay? So if you see the graph I got on my calculator, if I was to run my vertical line left to right, notice it's only intersecting my graph once everywhere I go. Okay? So that's what we're going to be looking at. So we're going to determine if the graph is a function. So let me try to draw my first one here. All right, so this one has a point here, and it's shooting up like that, and then it comes out like that. So is this a function? So here we go. I would run my vertical line left, and notice it's only intersecting once on my graph everywhere I go as I move my vertical line left to right. Right? It's only intersecting it once down here, once here. So no matter where I put my vertical line, it only intersects that graph once. So this is, yes, a function. Because vertical line does not intersect more than once. Hey, also, this ain't bad. You're just looking at the picture and you're just going to determine if it's a function or not. So let me draw another one. What if I had a circle? So this would be my next one, okay. So same thing, determine if it's a function. Well, let's see, let's run our vertical line left to right. Uh-oh, this one's intersecting here and here. That means it intersected twice, and it does that basically for the whole graph. So since that vertical line intersected me twice as I was running it through, this would be no, not a function. You know, that's all I'm going to do on these is just see how many times I hit it. Less than one or less. I mean, once, yes for a function. Two or more, no. All right, next. Same thing. I'm going to do two more pictures of these. This one has a graph that sort of looks like a crab but on its side. So the question, is that a function? So let's run our vertical line and see. Uh-oh. I'm intersecting it on the top and on the bottom of my vertical line. So since I intersected it more than once, this would be no, not a function. Oh, y'all, one more. And then we'll move into 2, 3. All right, so this looks basically like a jagged line there. So I would run my vertical line left to right. And notice I'm only intersecting it once everywhere I go. Looks like I'm just going to hit it once all the way through it. And since I've only intersected my graph once everywhere, this would be, yes, a function. Okay, y'all, so that was 2.2 dealing with our functions. So they went over the graphing with us. They went over finding those function values like f of 1 and f of 2. And then we did the vertical line test. So 2.3 will get into more function stuff, but we're going to play with other types of definitions in here. So y'all, here we go. 2.3.
Sir,
And this is going to, yeah.
before you get out of the graphs, my problem is I can't get it on the line. Like if you have to put the dot on the line or in between the line, it doesn't stay for me. That's my problem.
So I'll fix you in support.
Okay.
We'll pull your stuff up and I'll show you how to get that fixed. Because you can zoom in graphs in and try to get them on them lines better. That's a really sensitive graphing tool in that MATLAB. Yeah, so we'll get you fixed in there. All right, y'all, so watch. Let me pull this one up into MATLAB. So y'all give me a second. I'm going to pull up my MATLAB real quick. These ones are better to go through while we're looking at them for my first two on here. All right, I'm starting to get there in the portal now. All right, I made it to Blackboard, so let me get into the class and get this math lab pulled up. Oh, my internet running slow with this Zoom kicking. All right, let's see. And then what was it? Oh, 2.3. Nice, we're doing 2.3. That's domain and range. All right, so y'all should be seeing a clear screen. I'm waiting on my homework to load. Just trying to get there. It told me my internet was a little unstable. All right, so y'all see this first problem I got up here? It's telling me for the graph, determine the following. F of -4, the domain, any x values for which f of x equals 2, and then the range. So we really don't have to work this one out like equations. So what they want to know on part A, f of -4. They want to know what is the y value when x is -4. So y'all, let me zoom this graph in a little so y'all can see it good. All right, so the graph should be looking a lot better now. So to find f of -4, you would come over here and go to -4 on the x-axis and see what the y value is of that point. So what y'all think? F of -4 is going to equal what?
4.
4. There you go. So we would come over here, put in a 4, and then what we do? Check our answer. So it makes you check answers to each letter as you're going through it. Now, the domain. Now notice it says use a comma to separate answers as needed. Now they give me the fancy parentheses. All I got to do is put my numbers and separate them by comma. Remember, the domain is the x value. So the first point's x value would be -4. So you'd put -4, comma. Whoops, let me get into the box. So -4, comma. The next x value would be right here, and that's at -3, comma. Then I got one at -2, comma. I got a point at -1, comma. A point at 0, comma. Point at 1, comma. And then my last point is at the x of 2. So put all those x's in there and notice you had 1, 2, 3, 4, 5, 7 points. So you had to have 7 numbers in here. Check that. Next, this is the tricky part on here. It says any x values for which f of x equals 2. So here's f of x equals 2. That's 2 on the y-axis. So you're looking for any x values that equal 2 on the y. So this will be the first one, and that x is -2. So you would do the same thing, use a comma, put in -2, comma, and then this one also has a y value of 2, and it's on the x value of 0. So notice the difference. If they give you f of -4, they're giving you the x value and you're finding the y value. If they say what x is for which f of x equals 2, they're giving you the y value and they want you to give them the x's on that, okay? So then we would check that. And then the range, the same thing. But remember, the range is the y values. So this point right here has a y value. That had a y value of 1, so 1 comma. These points right here both have a y value of 2 comma. These 2 points both have a y value of 3 comma. And then these 2 points both have a y value of 4. Notice, since I had 2 points here, I didn't have to list it twice in my range, just once. So repeats don't have to be repeated in that actual domain and range, okay? All right, y'all, then we would check answer. And we're moving on to the next question, and it's going to be really similar to that one. So we'll do these, and then we'll play with the domain stuff. So let's zoom in this graph again. All right, so this one says, what is f of 3? So they're giving me the x value. I got to find the y value. So let's find 3 on the x-axis is right here. I go straight up, and that looks like that is at 2 on the y value. So that means f of 3 will equal 2. So now we check that. The domain. When y'all look at this, when these arrows go forever in each direction, the domain, I'm going to show you, is going to be this one right here, C. Because if you keep going to the left and left, it's headed towards what we call negative infinity. And I think if you hit more, it shows an infinity down here somewhere. Oh, it's right there. And then towards the right, if this keeps going and going and going, it's headed towards what we call positive infinity. Oh, hold on. We ain't learned all that yet, so scratch that. We're going to go down here to E. If this domain goes on forever and ever in each direction, it is for all real numbers. Now, the infinities would work, but I forgot they hadn't taught y'all that at this point. So our domain, if it goes forever, is called all real numbers. So check that. Next, any x values for which f of x equals 1. So I want to know 1 on the y-axis is going straight across here. I need to know what point's right here on the x and what point's right here on the x. So this first one is at 4. So I would put, oh, what happened? I got to continue. All right, so the first one is at 4. So I would put my 4 comma. And then we said y value of 2. So right here, y value of 1. So right here, that would be at an x value of 6. So you just got to find 1 on the y-axis and see where that crosses for those x's, okay? And then the range. So let's see. So the range is the y values. Notice the smallest y value is on the x-axis, which is at 0. And from 0, this thing heads forever. So that means, and it actually can equal to 0, so we're going to use the equals. So it looks like my range is any numbers that are equal to or greater than 0, because it keeps going up and up. So you would come over here, find the one that says greater than or equal to, and you would put a 0 in there. Remember, I can't use all real numbers because it don't go nowhere down here in these negative numbers, okay? It starts at 0 on the y-axis and heads up. So then you would check that answer and move on. So it should be getting into domain stuff, so I'm going to go back to my under screen. Let me make sure. Yeah, so we're going to stop this share and go back to our under screen. So we're going to be finding the domain of a function. So the domain of a function will be all real numbers unless. So the domain of a function is all real numbers unless there's 2 cases. Case number 1 is when we got fractions. If you have a fraction that b cannot equal 0 on the bottom of your fraction, okay? The second case would be a radical. The a under the radical has to be greater than or equal to 0. Now, we're not going to hit you with the radicals until we get to chapter 5, but in this section, you're worried about fractions. So remember, the bottom of a fraction cannot equal 0. And y'all, the calculator will prove that. Let's try this. 2 divided by 0 gives me an error because I tried to divide by 0. Which means when you're looking for a domain, you can't put numbers into the fraction that make it equal 0 on the bottom because there's no way to graph something that's undefined, okay? So, notice, we're going to be worried about fractions. So we're going to use what we call set builder notation. That's going to give you the big parentheses. Then you'll have X. There will be a bar. And then you put your conditions in. So let me explain what this stuff is. Let me get a better pen here. This X, it tells us what the variable is. This bar means such that. And then your conditions will be stuff like X is not equal to 5 or X cannot equal 7 or something like that. You'll see it when we do the problems. But this is set builder notation. We name the variable, have the bar such that, and then we put in our conditions. Now, I think the Math Lab basically gives you everything, and you're just putting in the conditions. Now, remember, I'm only worried about fractions. So, here's the thing. If we have fractions, we set the denominator not equal to 0, and solve. That gives us the numbers to exclude from the domain. Okay, because remember, the domain naturally is all real numbers, but when we got a fraction, we got to exclude some of these numbers that make it equal to 0 in the denominator. I'll let y'all catch up and then we'll do some of these problems. And that's really the last thing we're learning new in this section is about this domain. So y'all, we're gonna have a few problems finding that domain. So these will say, find the domain of the function. So these would start about number 3 for y'all. The first one I got, f of x equals 13 over x plus 10. So let me show you if I was to graph that on my calculator real quick. I would do 13 divided by. Now, anytime you do fractions in a calculator, if you got more than one part, you got to put that part in parentheses. So since the x plus 10 made 2 parts, I got to put the x plus 10 in parentheses in the calculator so that it knows that that's the bottom of the fraction. Now, here's the other way you could do that. This is tricky, but if you hit alpha and y equals, you see where it says ND, that means fraction. So watch this, because that's numerator, denominator. When I hit enter, it puts it in like that, and I can put the 13 on top, and then arrow down and put in the x plus 10. If you do it like that, then you don't have to worry about parentheses because you made it look like that fraction. Either way. So to do that, I hit second y equals to get fractions. All right, so I want y'all to see this table. So second table. So let's see, that's going to be a negative number. So the only number that'll make that equal 0 would be a negative 10, right? So watch what happens when I click on negative 10. I get a error because that negative 10 made that equal 0, and you cannot divide by 0. So what we'll learn later in chapter 5, I think it is, when they're undefined like that, they make what we call vertical asymptotes. But we'll worry about that later, okay? Right now, we just want to find the domain on these. So we said we would take the bottom, x plus 10, and set it not equal to 0. All right, solve just like you would if that was the equals. Get the x by itself by subtracting 10. And notice this tells me x cannot equal a negative 10. So my answer would be x such that x is not equal to negative 10. So basically your answer makes the condition on this, okay? All right, then you would move to 4. So y'all, 4 has P of x equals 2x minus 9. Now remember a while ago I said the domain of a function is all real numbers unless you have a fraction or you have a radical. I have neither. Since I have no radicals and no fractions, my answer would be x such that x is a real number. That means whatever number you put in here, I can multiply by 2 and subtract 9. There's nothing that'll make that undefined or imaginary, okay? So no fractions to worry about on this one. Okay? So then you would move to number 5. Number 5 is P of x equals x squared plus 1. So we're not worried about this one, right? Because I don't see no fraction. I don't see no radicals. And any number I square will give me a number plus 1, right? So this will work for any number, whether it's negative or positive. So this will be x such that x is a real number. And once again, it was because there were no fractions to worry about. So y'all see the idea? If it's a fraction, I got to worry about that bottom equaling 0. But if I don't have a fraction, it's going to be all real numbers and I move on. Okay? How about g of x equals 9 over 9 minus 5x. So we do have a fraction. So since I have a fraction, I'm going to set that bottom 9 minus 5x cannot equal 0. So I solve that, and then it'll give me the numbers I got to get rid of. So y'all, 2 ways to solve this. The first way would be to subtract 9 from both sides. And I get negative 5x cannot equal negative 9. The second way you could have started was add the 5x and make it over on this side, but it don't matter which way you go. Now, what I do got to do is divide both these by negative 5. So negative 5 divided by negative 5 makes that a positive x. That cannot equal negative divided by negative makes that a positive, and we cannot reduce the 9/5. So that would be our final answer. So we would get x such that x cannot equal 9/5. And I think actually what they say in Math Lab, they do x such that x is a real number and x cannot equal 9/5. I think they put this in front of all of them, but what we're looking for mainly is what's happening at the end on these, okay? So we knew x cannot equal 9/5, but in Math Lab, I think they always put this real number part in front of them all, okay? All right, y'all, 2 more of these. P of x is going to equal the absolute value of a x minus 8. Well, no fraction to worry about. No radicals to worry about. I can take the absolute value of any number, so I ain't got no restrictions on that. So since I have no fractions to worry about, this is going to work for all real numbers. So x such that x is a real number. Now y'all remember this. Every number is a real number except for undefined and imaginary numbers, okay? Y'all should have learned about imaginary numbers if you tried to take square roots of negative numbers. Right, y'all, so one more will be number 8. And this will be the last of 2.3. This one has P of x equals x to the third minus 6. Well, once again, there is no fractions to worry about. So this domain will be all real numbers. So x such that x is a real number. Now, y'all, later on in life, when we hit chapter 5 and we do this domain again, we will throw stuff on the bottom with x squareds in it. So that's going to bring back your factoring skills, okay? Alrighty, so I'm going to stop my share. And then I'm going to stop my video. So this will be